Hello children. Okay, how are you all? Welcome to the second lecture of chapter 2 for class 9th. Okay, so in this second lecture for chapter 2 we'll study about colloids. What are the meaning of the colloids? How do we identify colloids and what are the various types of the colloids? Fine. Come, let us study about colloids. What are colloids? Colloids are heterogeneous mixtures which appear homogeneous. That means they look as if they are homogeneous. Why do they appear homogeneous? Because the particles that make up the colloids, they are very small. Fine. So the colloids are made up of particles which are very small and they cannot be seen by the naked eyes. Thus they appear homogeneous, but in reality they are heterogeneous. Some examples of colloids are milk, air, butter, etc. Now what are the properties of colloids? Let us study about the first property of colloids. Colloids are heterogeneous mixtures. That means they do not have uniform composition and appearance. Okay? Heterogeneous means the composition and the appearance is not uniform. The second property is the particle size is very small and cannot be seen by the naked eyes. Third property is the mixture is stable. That means if you leave the mixture as such, the constituents of the mixture are not separated. Okay, if you are leaving the mixture undisturbed, its constituents do not get separated. This you must have seen in case of milk or air. The fourth property is the constituents cannot be separated by filtration. Instead, the constituents are separated by the process which is known as centrifugation. We'll study about centrifugation in the further coming lectures. Okay. So why can't the constituents be separated by filtration? Because the pores of the filter paper is large enough, it allows both the solute and the solvent particle of the colloid to pass through it. And coming to the last property of colloid, the particle size of the colloid is big enough to scatter light and show Tyndall effect. In the previous lecture we had studied about Tyndall effect, and this effect can be seen by the particles of light, the particles of solute. If the particles of solute are large enough, they can scatter light. And I have given you the example of a picture hall or cinema hall where the path of light can be seen. Why? Because the dust particles scatter the light and they make the path of light visible. So this Tyndall effect, phenomena of Tyndall effect is seen in case of colloids. Why is it seen? Because the colloid particles are big enough in size and they can scatter the light and they can make the path of light visible. Okay. So this is known as Tyndall effect. Now let us study about the various types of colloids. Fine. There are 8 types of colloids. As I just said, colloid is also made up of a solute and a solvent. Just like other mixtures, colloid is also made up of solute and solvent. So what is the solute? Solute is the portion which is taken in less amount, and solute is also known as dispersed phase. In case of colloids, the solute is called dispersed phase and it is taken in less amount, whereas the solvent is taken in large amount and it is called dispersed medium. In colloid, the solvent is taken in large amount and it is called dispersed medium. So now let us look at the table. When the dispersed phase is liquid, that means when the liquid is dispersed in gas, this type of colloid is known as aerosol. And where do we see this colloid? This colloid can be seen in clouds and fog. Fog and clouds are the example of aerosol. When solid is dispersed in gas, this is also known as aerosol. So you can see wherever the dispersed medium is a gas, the term aerosol is used, and the example of solid dispersed in gas is air or smoke. You are already aware of this example. Air has dust particles which is dispersed in gas. The third category is gas. Gas is the dispersed phase which is dispersed in liquid. So a gas dispersed in liquid is known as foam. Foam is the same thing that you can see when we mix detergent to water, and the example of a foam is shaving cream. So all of you are aware of shaving cream. Shaving cream is an example of colloid. What type of colloid is it? It is a foam. Coming on to the fourth one, when a liquid is dispersed in another liquid. When the dispersed phase and the dispersed medium, both of them are liquid, the name of the colloid is emulsion. It is a special type of colloid which is known as emulsion. And the example of emulsion which all of us are aware of is milk. Milk is a colloid where the dispersed phase and the dispersed medium, both of them are liquids. The fifth one, solid dispersed in liquid. When solid is dispersed in liquid, that means solid is taken in less quantity and liquid is taken in large quantity. Such a colloid is known as sol. S-O-L is the name. And where do we see such a colloid? Such a colloid can be seen in paints. The paints that we use for coloring the doors and the windows, and the mud. The mud is an example of, or we can say the pond water which contains solid dispersed in liquid. So that is also an example of sol. Next, gas. Gas is the dispersed phase, gas dispersed in solid. The example is foam. So gas dispersed in liquid is also foam. Gas dispersed in solid is also foam. The example of such a colloid is sponge. Sponge. Okay, the sponge balls that you used to play with at your childhood. The rubber and the pumice stone. Fine. Coming to the seventh example, liquid dispersed in solid. Whenever a liquid is dispersed in solid, what is the name of such a colloid? The name of such a colloid is G-E-L, gel. You can see the seventh number, it is called gel. So liquid dispersed in solid is called gel, and the example of such a colloid is cheese, butter, or the jelly, just jelly that is available, and the children are very fond of just jelly. So that's an example of gel. And the last, eighth one, solid dispersed in another solid. The name of such a colloid is solid sol. Okay, solid dispersed in solid is called solid sol. The example of such a colloid is gemstone or the colored glass. So these are the various types of colloids. Okay, now let us study about the suspension. Come, let us study about suspensions. So this is third type of mixtures. Okay, suspensions. Suspensions are heterogeneous mixtures where the solute particles are heavy and thus they remain suspended or they settle down in the solvent. Okay, the solute particles which are put in the suspension, they are very heavy, so either they remain suspended, okay, or they settle down gradually. Where can we see suspension? Suspension can be seen in when chalk powder is mixed with water. Example of suspension, chalk powder mixed with water. Okay, or we can also write fine sand particles. Fine sand particles with water. When fine sand particle is mixed with water, that also forms a suspension. Okay, now come, let us study about the properties of suspension. The first property we have already studied about. The particles are, the mixture is heterogeneous in nature. That means it doesn't have a uniform composition and uniform appearance. Why is the composition and appearance non-uniform? Because the particle size of the solute is large and it gradually settles down. So this can never give a uniform appearance and the composition. Next, the particle size is so large, so we can see it by the naked eyes. The particle size is large enough, so it is very well visible to our naked eyes. Third one, the solute particles scatter the beam of light passing through it. So the suspensions show Tyndall effect. So Tyndall effect is shown by the suspensions and the colloid, and it is not shown by the true solutions. Why is it shown by the Tyndall effect is shown by the suspensions? Why? Because the solute particle size in suspension is very large. So it scatters the light. When the light passes through a suspension, the solute particles scatter the light, and as a result the path of the light is visible, and so we say that the Tyndall effect is seen in case of suspensions. The suspensions form unstable mixture. Unstable mixture means if you leave a suspension as such, you do not disturb it, then you will see that the solute particles slowly get separated. Okay, so the solute particles slowly get separated if the mixture is left undisturbed. And the last property is that the solute particles are large enough so they can be separated by the filtration, because the filter paper pores are small as compared to the solute particles. So if you want to separate the constituents of chalk powder and water, this suspension, and if you try to filter it on the filter paper, you will get the chalk powder as a residue and water will be collected as the filtrate. Okay. Now these suspensions do not form a transparent mixture. The mixture that a suspension forms is non-transparent. So which mixture is transparent? Only the true solutions are transparent. Remember that. Colloids are also non-transparent. They are translucent mixtures. Okay. Now coming to the particle size. Particle size, when we compare the particle size of true solutions, colloids and suspensions, the largest particle size is seen in suspensions. The size of the suspension solute particles is 10 to the power of minus 5 nanometer or more than this. Okay. 10 to the power of minus 5 nanometer. Sorry children, this is 10 to the power of minus 5 meter, not nanometer. Is that clear? The colloids show a size range of 1 to 1000 nanometer, whereas true solution, the solute particles are less than 1 nanometer. Okay, the size range is always, the solute particles are smaller than 1 nanometer. Now I missed one topic here, that is Brownian motion. So what is Brownian motion? Brownian motion is a zigzag motion, okay, seen in case of the colloids. The zigzag motion of the solute particles. Remember, where do we see this? It is seen in colloids, zigzag motion of solute. And where do we see this? It is always seen in case of colloids. Why? Because the colloid particles, okay, there's a spelling mistake, Brownian motion. Fine. B-R-O-W-N-I-N, Brownian motion. This is a zigzag motion which is seen in case of solute particles of only colloids. Okay, why? Because the colloids have intermediate solute particle size and they can move in a zigzag fashion. Okay, and the true solutions have very small solute particle size, so they do not show Brownian motion, whereas the suspensions have a very large particle size. So thus they also do not show the Brownian motion. With this I come to the end of the lecture 2 of chapter 2 class 9. Now we are left with the separation techniques which we'll deal with in the next lecture. Thank you children and have a nice day. Till then, till we meet again, take care of yourselves. Bye-bye.